Hey everyone, so I speak English, and the odds are most of you speak some kind of language, whether it's English, Japanese, Spanish, Korean, you speak something, right? Well, your computer speaks a language too, and that language is called binary. Now, some of you know exactly what binary is. Some of you know that it has something to do with ones and zeros, and I'm going to try to explain it in the best way I can today. So, the language of your computer and all of its hardware is binary. It's how it speaks to each other. Now, the reason we use binary is because it's simple. Binary is base 2. All right, so there are two possible states to binary, either on or off, 1 or 0. Okay, think about it like a magnet. Magnets have two states. They have the north, they have the south. All right, they are charged, they are not charged. All right, so it's very and there's a connection between those two that we're not really going to go into today because it's kind of beyond the scope of this lesson. But just know that binary has two states, and it's easy. All right, so it's just the same thing over and over and over. Now, in computing, we use something called 8-bit, which is 8 individual on or off states together, which form what we call a byte. So all these terms are kind of coming into your head. You've got all these bits and bytes, and we're going to try to explain that in a little demo that I have for you right now. So let's check this out. So here we have a really good representation of 8-bit. All right, so we have each individual penny that we have here is 1 bit, and together all 8 of them make up 1 byte. All right, so we have and then we have the values of each state. So each penny has an off state, which is black, and an on state, which is the copper side. Okay, so right now we would have only this spot would be on. All of these would be turned off. So these are not adding any value to our overall number. So what we have, if we turn this one over back to black, is all of them are off, which gives us a value of 0. Nothing is being added. Now, you can see what I meant by base 2 because every time we go to a new spot, it's doubling the value of that spot. All right, so we have up to 128. Now, if you're really good at math and you did this really fast, you realize that we have up to 256 possible numbers that we can create using these pennies. So, and that includes state 0. Now, remember, in computing, most of the time we're going to start at state 0. In programming and in binary, we're going to start at state 0. So we have, let's change these over and let's create a few numbers. So like I said before, if we turn on this first one, so this would be a representation of 1, 0, 0, 0, 0, 0, 0, 0. Now, that's not actually correct because remember, we always read in this direction with binary. So it would be 0, 0, 0, 0, 0, 0, 0, 1. So if this is the only one that's on, we have a value of 1. All right. Now, if we turn on this value, all right, so let's turn on our 2 value, and we'll leave our 1 on for now. We have 0, 0, 0, 0, 0, 0, 1, 1, which is going to equal 3. 1 plus 2 equals 3. So that's how you would represent the number 3 in binary. Now, let's make it a little bit more difficult. Let's turn off our 2 state, and let's turn on our 8 state. So here we have 0, 0, 0, 0, 1, 0, 0, 1. So this is a new binary number. 8 plus 1 would equal 9. So this is how we represent the number 9 in binary. All right, and then let's just throw on another one. Here we go. We throw on our 64. 64 plus the 9 that we already had, all right, is going to be 73. So 0, 1, 0, 0, 1, 0, 0, 1 is equal to 73. So that is how we represent numbers using 8-bit. So now that you know how to read binary values or 8-bit binary values, how are you going? So now you're thinking, okay, well, that's cool. I know how to represent 255 or 256 values, 0 to 255. But how does my computer translate my letters that I'm typing or my characters that I'm typing into these numbers? So how does it get that from that? And we need to take a look at a special chart to see how that works. So this scary little chart here is called the ASCII table. So ASCII characters are basically 256 characters, very simple characters that our computer can translate an 8-bit number into to get the character. Now, there are a lot more characters, you know this. There are a lot more characters on your computer than just 256. So we do have more tables, but this is probably as simple as it gets. So we have right here is the decimal value. That decimal value is that number that I just showed you. So we made in the number 73. All right, so we used our example to make the number 73. Well, let's look at what the number 73 represents. So 73 would represent the capital letter I. So when your computer, when you type in the letter I, in order for your computer to see what that letter I is, it's going to send 01, 001, 001. So it's going to send 8 bits as fast as it can through your computer so that it can tell that, oh, that's the letter I because it's represented by the decimal 73 in 8-bit. So we tend to take this for granted. We don't realize that whenever we're typing, all these letters are coming in so fast and we're throwing in all these characters. But every single time you type one, every single time your computer has to see one of those, it is throwing 8 bits through your computer, which is really cool because it does it so fast. And that's why our computers have to move so ridiculously fast. Now you'll see some characters in here that you don't really understand. I'm not really sure what this one is. We have like some accent marks, even some blocks and some values, and some of these we don't understand, but just know that these are the original 256 characters that your computer can understand. So that's it for binary. So now you know the language that your computer speaks, and you could, in theory, you could just type all these binary values out and speak to your computer directly if you want, but luckily we have software that does this for us. So we never have to type in machine language or binary ever again. We have software that translates all this stuff for us. All right, so good luck with the modules in this lesson, and I'll see you in the next video.